In this video, we're going to take a look at some synthesis examples involving some of the reactions that we've learned so far this chapter. So in terms of the new reactions we've learned this chapter, we have the Gabriel synthesis, the azide synthesis, reductive amination, and alkylation. So which of these types of ways to make amines we want to use depends on our source of nitrogen and what type of amine we want to make. If we're starting with phthalimide as our source of nitrogen, then obviously we're going to go with the Gabriel synthesis. Same thing with the azide synthesis if we're starting with an azide ion. If we're told that we are starting with ammonia, then that's a clue that we're going to be using reductive amination. The other thing to keep in mind is the Gabriel synthesis and the azide synthesis are only good for making primary amines. If we want to use one of our new reactions to make secondary or tertiary amines, we have to use reductive amination. And then the alkylation is really only useful if my goal is to make a quaternary ammonium ion. So in this first example, we're going to synthesize this compound two ways. In the first way, we have to use ammonia as my source of nitrogens. So that's telling me I'm going to have to use reductive amination. Now I also see that my product is a secondary amine. If I'm using nitrogen in reductive amination, that can give me a primary amine, so I'm going to have to do this in two steps. So I'll do two reductive aminations. So I need to add these two carbon-nitrogen bonds in my reductive amination steps. Which one I do in which order doesn't really matter. I'll start with the cyclohexane just because it's bigger. So in reductive amination, my starting material has to be an aldehyde or a ketone where the carbonyl group is where I want the carbon-nitrogen bond to end up. So I have my starting material. Here's my ammonia, and then my reducing agent. And so I've created an amine. Now in the next step, I need to add on this ethyl group to the nitrogen, but now this is the amine that I'm going to be reacting with the carbonyl compound. And so for this second reductive amination step, I'll still have H3O plus, but now the thing that I need to add to this is, in this case, the aldehyde, and then I need the reducing agent again. And so then this will react to give me the final product. Okay, we're going to synthesize the same compound, but now we're going to use phthalimide as our only source of nitrogens. So this is telling me that I'm going to need to use the Gabriel synthesis. Now the Gabriel synthesis is only good for making primary amines, so I can make the primary amine using the Gabriel synthesis, but then I'll have to follow that up with a reductive amination step in order to get the secondary amine. Now, in the previous example, when I was just doing two reductive aminations, it didn't really matter which amine I made first, or which carbon-nitrogen bond I made first. In this case, it does matter, right? So I can either react the phthalimide with this cyclohexane with a halogen coming off, or with this ethane with a halogen coming off. Now the Gabriel synthesis is an SN2 reaction, so that's going to work best with primary alkyl halides. So I think I want to choose to make this amine first because I can do that with a primary alkyl halide, whereas if I try to make this amine, that's going to be reacting with a secondary alkyl halide, which won't work as well in an SN2 process. So to make that first amine, we'll start with the phthalimide, then in the Gabriel synthesis, We need potassium hydroxide to deprotonate that nitrogen. Then I need the alkyl halide, where the halogen is where I want the amine to end up. I guess in the case of bromoethane, it doesn't matter, but good to remember for other synthesis problems. And then hydrazine will release the amine from the rest of the phthalimide molecule. So that's going to give me this primary amine, and then I can use reductive amination to get the final product. So I already have the amine, so it's the carbonyl compound that I'm going to need to react with it. And so that should give me the final product. Okay, in the second example, we're going from an alcohol to an amine. And my carbon skeleton has also changed. I've gone from 1, 2, 3, 4, 5, 6 carbons in the longest chain to 1, 2, 3, 4, 5. So we've learned a lot of ways to make carbon-carbon bonds. We've only learned a couple that will break carbon-carbon bonds. And one that comes to mind in this case is ozonolysis. If I can make this an alkene, I can chop it off with ozonolysis, and then the product of that step is also going to be, in this case, an aldehyde, and that's advantageous because I know that I can turn an aldehyde into an amine with reductive amination. And so my first goal is to get this double bond here and then break that with ozonolysis. So I need to eliminate this OH. I can't use concentrated sulfuric acid because that's going to give me the more substituted alkene. So I need to turn this into a good leaving group. And so I'm going to use TSCl and pyridine. Now I can use a bulky base to give me the less substituted alkene. Now I can use ozonolysis. So that chopped off this last carbon, left me with, in this case, an aldehyde. And so now my last step, I just need to change that into an amine. And I can do that using reductive amination with ammonia. And that should give me the final product. Okay, in this final example, I'm making a secondary amine, so that's making me think reductive amination again. But I also notice from the starting material, I've also added another carbon here. And so that makes me think of a method that we learned prior to this chapter for making amines. And so that would be going from an alkyl halide, doing an SN2 reaction to replace that with a cyanide ion, and then reducing that with lithium aluminum hydride. And so that'll give me this amine, and then I can use reductive amination to get the secondary amine. So of course I'm starting with no functional groups, and so the way to get a functional group on an alkane is to use radical bromination. Then I can do SN2 reaction with sodium cyanide, reduce that to an amine, and then I can use reductive amination to give me my final product. And that should do it.